Hello everyone, my name is Jeremy Brown and this is Summer of Fuzz, August 2021 at the DevCon 29 AppSec Village, macOS edition. Quick run through the agenda. We'll take a walkthrough of some of the debugging tools used on Mac for fuzzing, talk about SIP and the app Sandbox, crash reporting, how to deal with sleep and SSH stuff, looking at process execution, enumerating file and URL handlers, client and network services, how to discover those, and then talk about fuzzing the different CLI and GUI apps, fuzzing network clients and servers again, and some of the bugs found. Then finish off with a conclusion. So who am I? Mostly interested in bug hunting, fuzzing, offensive security these days. Previously doing security stuff at Microsoft, Amazon, NVIDIA to name a few. Like breaking stuff. Of course, that feeds into attacking different products and services, and for the most part, helping them get in better shape before release, as well as a ton of other security stuff. I like various different domains, native code, web services, cloud, containers type stuff is all interesting as well. So intro, I didn't know much about Mac security before doing this research. I was pretty new to Mac in general. It's always one of those things where it's like, it's on Mac, how do I, everything is so different than the Windows and Linux world. A lot of similarities with Linux, but just it was kind of a learning curve just getting into it and trying to wrap your head around all this stuff. But I've been fuzzing for a while now, and there's so many advances these days, especially with AFL++ and all the interesting stuff coming out of that area and innovations there. But I really wanted to look at it at a different angle. I wanted to kind of forget a lot of what I already knew and what was conventional wisdom and what, everything about instrumentation these days, and got to make it super fast and scale and all this stuff. And there's so many targets that just make it really hard to make a fuzzer that does, that is kind of general purpose, that handles all these different targets, but is really good at all those, very innovative stuff that's happening in fuzzing these days. So I want to build something from scratch that really serves a purpose, and that makes it easy to fuzz a lot of different things, although making some trade-offs. And of course, this ties into Mac because a lot of the targets I'll be showing how to fuzz these days and how to set up fuzzing for that will get you started fuzzing userland stuff on Mac. So I'm mostly looking at core, a lot of the default applications on OS X. Like I said, again, client and GUI apps, stuff that parses stuff on the command line, files. But a lot of more interesting stuff is actually fuzzing the GUI part, which AFL can have a hard time doing. And of course the network services and how to fuzz network stuff natively with a fuzzer. And then how to set up the environment for debugging. There's a lot of stuff to know to actually get started fuzzing and being able to debug and triage crashes and things like that on Mac. Again, we're not trying to do something that scales for a huge fuzzing farm. A lot of this stuff you can automate to make the tooling do that, but this is a lot of these things you can reproduce at home with a MacBook and still have fun finding bugs. So related prior work, Ben Nagy's always got a ton of good stuff on fuzzing OS X and some tooling around that. Crash Wrangler, there's some pretty good stuff there too. And the inspiration for getting back in fuzzing for me was this tipout.sh zine article, which was pretty interesting. It really made me think, wow, you can start over with something super simple and still be effective. So debugging. Xcode is your development package. There's a headless script you can find online that I've referenced, and you want to enable developer mode. So pretty straightforward, enable developer mode. That's going to help you do a lot of debugging stuff, especially in a non-interactive way. And then guard malloc. So this is a malloc helper that can help you find some subtle memory corruption bugs. You can use it, you can just pass the environmental argument to the library and then run your run your target and the arguments, and it will basically help you find crashes a little bit easier, and more crashes too that you may have missed by not instrumenting and using this library. And you can read more about that at libgmalloc, but that's available on OS X. Then LLDB is the debugger of choice on Mac. GDB, I had a hard time getting it working, and it's sort of, the LLDB it's a nice interface, nice environment. A lot of stuff's already set up for Mac, so probably recommend using that. Excuse me. And you can automate a lot of the crash triage and produce bucketing data. You can parse the debugger logs for to sort things by PC, the return address, the program counter, the instruction pointer, all that stuff. Look at the back traces. A lot of this stuff you can just pass with -O, which is just passing different one-line commands to LLDB. And this is how you do automated crash triage in a very simple way. SIP is an interesting one on Mac, so system integrity protection. It does a bunch of different stuff, restricts the root user, sign processes, protects /system, all that stuff. For debugging and for fuzzing stuff, you're going to want to either enable SIP without a certain mode, or just disable entirely while you're using it for that. Because that's going to get in the way of a lot of, again, debugging app stuff that you're going to want to utilize for fuzzing. So on a physical machine, you can reboot in recovery mode and then disable it, or again, enable it without debug. So that will give you some debug privileges, essentially. And if you're using VMware Fusion or any other, virtual environment for Mac for fuzzing and debugging, there's a bunch of steps. There's a few blog articles that go over it, but essentially you have to do some special steps to get around startup disk and restart the firmware and get this stuff to work on the latest OS X and OS 11. So yeah, on Big Sur it's a little bit different, and all this stuff. But essentially, you want to enable this to be able to debug on OS X. And the App Sandbox, it's another interesting one that can get in the way of fuzzing. It's not, you can work around it, but it is something just to keep in mind when you are trying to fuzz, for example, GUIs, because a lot of files can only be opened in certain locations. So let's say you mutated files that are in temp, and you place your fuzz files in temp or wherever on the file system. If you try to open that with some apps, you'll get, it can't be opened because you don't have permission. So if you check the logs, you can see it's being denied. The Sandbox is actually denying that file read. There's other directories you can put them. So again, if you can if you can manipulate the file system, if you can write in certain places, you can figure out where they want to see files open from. And of course, you can still double click and open the EPUB file from downloads directory and stuff. But for local fuzzing, you're going to want to place them in somewhere that when the target is launched, it looks like it's in a good location, and the Sandbox is happy with it. So a report crash is an interesting one. Generally, if you're fuzzing and you're catching your own crashes and stuff, you can just disable it. It may just, if nothing else for perf issues, you may be worried about crash reports being sent to Apple, stuff like that. There's other things you can work around for submit diag info. But if you want to disable it for the most part, that can be useful. But also, you can use it you can use it to your advantage when fuzzing, because if you enable it in certain cases, it will help you, and you can actually use those crash logs that it catches and puts in the diagnostic logs folder for triage. So if there's a scenario, say we're fuzzing a UDP server where it's kind of hard to catch crashes. If you're fuzzing it from like a black box, gray box approach, you can attach it if you can attach to it and run it in debugger, catch crashes, that's great. Sometimes for whatever reason you can't. And in that case, we could monitor the diagnostic logs folder to look for crashes, to know when there is a crash, things like that. So it can actually help to enable report crash in certain cases. And sleep. Super important for humans, but on a Mac, it gets really annoying when you're fuzzing and all of a sudden your session is disconnected because it went to sleep. And there's like 10 different sleep modes on Mac. They're super eco-friendly in that way, which is great when you're just using it as a user, but when you're fuzzing, I need the OS to be super awake all the time. And so there's a bunch of different ways you can do it. System sleep, TM set. You can use keeping you awake on the desktop side. And there's still some more work to do with SSH, though. So with SSH, it's nice to be able to fuzz GUIs over SSH instead of the physical session. You don't have to have physical access to fuzz things like that. It'll just open up from the command line on your desktop session. But SSH can, depending on your network and the environment and stuff like that, it can be a pain to get it to not disconnect your sessions in the middle of fuzzing. So I wrote a bunch of stuff into a fuzzer that tries to help with this by doing like these custom console pings to make sure it's always alive and things like that. But yeah, surprisingly, it can be a lot of work just to make it not disconnect your session a lot. So one way to do it is modify your daemon config to do keep alives and 0 for the client alive stuff, and then restart the daemon. This may not work for everyone, and again, the network environment, how many, whatever's going on in your network, how many disconnections you normally get, or things like that can factor in. But this is one way I found to do it to avoid that. So for monitoring process execution, see what's going on in the system, there's a really handy dtrace script that's included on Mac now called newprocd. And you can use this, again, if you disabled SIP or gave yourself debug privileges. You can use this to see all the stuff that's being executed and the command line args for that, which is super useful for looking at, what is the attack surface here? And you can see different stuff happening, like turning off file sharing, turning on VNC stuff, turning on printer sharing, all those things. When you're launching apps, you can see what args are being launched. Although with XPC proxy, that sort of does a lot of stuff under the hood instead of on the console, which makes things a little bit harder to debug or see what's actually going on. But dtrace is amazing and super helpful for process execution stuff. For enumerating the handlers, I came across the Swift default apps. Pretty cool project. It's got a SWDA program that will give you all the URI handlers. So you can see what applications are handling address book, AFP, CFS, FaceTime stuff, files, all that stuff. And you can see there's 101 different handlers. So yeah, plenty of interesting stuff to poke at there. And then for the file handlers, you can see what stuff is actually handling the different file types that are registered on Mac. So your Flash videos, PDFs, archives, you can see archives handled by archive utility, things like that. If you do a list, there's 420 different file formats that are registered to an application. Yeah, if you imagine half or whatever are valid and they're actually going to map to something that's actually parsing the file format, that's still a ton of attack surface there. So lots of good stuff. It doesn't necessarily tell you the file extensions. So for example, the Apple script, it doesn't tell you exactly what the file type may be, or the file extension that you would want to look for to get test cases to fuzz with, for example. But so you may have to do a little bit of work for that when you start targeting an application. But for the most part, it's super helpful. Looking at network processes, again, we can use dtrace to capture the different receive calls or sends that are coming across the network. and we can see which processes are actually receiving network data and probably operating on that network data. You can also just turn on everything, system preferences, sharing, turn on everything, look at netstat. You get a good idea of what's listening. You can use LSOF to look at more process information and other tooling too. Yeah, that's one way to look at the network services that are listening. So for fuzzing. AFL, if you try to run traditional AFL on Mac, it doesn't work so well. It doesn't think a lot of things are MacO, even though it's supposed to know how to recognize those. AFL++, again, ton of new development there. Looks like they got that figured out, so you can use AFL++ when you're fuzzing on Mac on simple console applications, things like that. But what about GUI apps? It doesn't work so well. Just fundamentally the way it's designed, it just doesn't optimize for doing things like that. It's looking for the program to exit, for example, and a lot of GUI apps you need to exit them manually if you're going to open them. What about network fuzzing? Windows. WinAFL and AFLNet, a lot of respect goes to them. Very interesting projects, but they have some limitations too, and there's quite a bit of setup that goes along with them. So, wrote a new fuzzer recently that we'll be releasing in a few weeks if all goes well, called LightFuzz. It just works. That's the biggest theme. I wanted a fuzzer that I didn't need a different setup on Mac. I didn't need a different setup on Windows. It worked on Linux. I wanted to support file network fuzzing. I want to be able to fuzz GUIs, even interactive ones like Postman or FileZilla, stuff like that. You always want automatic crash triage, diffing, as much information, as much artifacts as possible that you can create to give yourself a good analysis and a way to repro different crashes. LightFuzz is most useful for closed source applications. Again, clients and servers, that's sort of what it was meant for. Of course, you can do open source libraries and stuff too. And it's really built for bug hunters. It does some pretty interesting things, unorthodox fashion. And it's able to sort of live off the land in a way. And I'll talk about the trade-offs here in a moment for that. So it breaks a lot of the rules for modern fuzzing. These days everything is about how fast can we do it? How can we instrument this? Like how can we get down and get code coverage for every single iteration? How can we fuzz it? A million iterations, things like that. LightFuzz doesn't do that. It says, okay, I want to cover all these different domains, and I want to be able to not have to worry about cross-platform problems for the most part, other than if-defs and stuff. And I want to make it super simple to set up, and I don't want it to fail. It only works on this type of application, or you got to spend several hours instrumenting this app or getting it set up. I want to make a trade-off to forget a lot of that stuff and just say, okay, it can fuzz black box apps, it can fuzz open source, but it doesn't need tons and tons of time to get set up. You can start fuzzing as soon as you get some test cases for the most part on 3 different major platforms. It doesn't have the DevOps integration stuff with automatic bug filing and all things like that. Of course, it can be written around that, and that can be a feature. But most importantly, what should be judged by for a bug hunter, does it find bugs? Does it find bugs? Does it do does it do what it was meant to do? Like if you're fuzzing and you're not finding any bug, like you have all this infrastructure set up and everything's going great, but if you're not finding bugs and you're not getting like actionable stuff out of the tooling, you can measure it how you like, but I like to find bugs. But then you ask, how do I know the fuzzer's doing a good job? Have we compared it against other fuzzers? Have we did things like that? How does it stack against AFL other than the stuff we talked about? Does it find bugs? That's what I'm optimizing towards. and I've acknowledged the trade-offs there too. So with Fuzzing Mac, there's some intricacies around GUI apps. For example, notice when there's fuzzing, some apps, they like unique file names. If you give them another file name, maybe they cached it or maybe they remember it somehow, and doesn't fuzz so well like that. So they like unique file names, some apps at least. They also prefer to have the right extension in a lot of times. So you don't want to just create a bunch of files that are named .fuzz. You try to copy the input file name, the test case, whatever it was named on the extension as much as possible to make it look like a legit file. So the parser is more willing to not bail when it looks at it and says, oh, I don't know what .fuzz is, but I know what .pdf is, for example. And again, with reading files within the Sandbox, you may need to place the test cases in a certain folder, which of course is an easy command line thing to do, to choose that. But some things are just hard to fuzz directly. So sometimes passing a command line arg, it just won't accept it. It wants it through another piece of plumbing somewhere, through IPC, for example. But many of the classic apps and a lot of the stuff on Mac still work as command line apps, for example. So still quite a bit of attack surface to tackle there. So for targeting application, do a CLI or a GUI. We're going to look at iBooks, font book, package util. Collect the test files. Again, if it's not a known extension, and it may not open it, and you need to specify if it only will open it from certain locations, like the container locations, you need to specify that as well. If the target doesn't exit on its own, for example, GUI apps for the most part, measure a reasonable timeout, give it enough time to parse the data, and then kill the process, and then start fuzzing. So with iBooks, and I'm just going to demo some ways to use light fuzz to these things, and you can infer some of how it works from there. Specify local mode, and then the command would be the target application plus the keyword fuzz, which basically says put the fuzz file here and make that command to execute. You can also do stdin on most of the platforms by not specifying anything, and it will just read the test case and then throw that to the target's stdin. Input files, give it some EPUB files, specify an output folder, just a specific one, or automatically goes to the crashes directory, the root crash directory. And then give it a special temp directory. So normally it would go in temp/lightfuzz/ the run number. Each one gets its own folder. Each fuzzing session gets its own folder, but you could specify the temp directory to be the container directory so that iBooks actually will open it. Max running time, again, you're screaming, oh, that's going to take forever. Hey, we're fuzzing a GUI app. So yeah, there's, again, some trade-offs to be made for GUI app fuzzing if you can't directly hit the harness. Number of iterations, and then easy, which we'll talk about soon. And then with FontBook, mostly the same thing, except FontBook doesn't need the special temp directory. Easy is basically the E option is to recycle any of the crashes found. So when you're fuzzing and it finds crashes, it'll actually put that crash directory as the input directory at the end of the session, and it'll try to go through and mutate all of the crashing input to see if it can get any other, different crash points and things like that. So it's just a fun little feature that I thought of doing. And the Z option is to enable any malloc helpers, such as the glib malloc that we talked about earlier, to help find some more subtle crashes. So that's just enabling it when we run the application in the environment. Package util is a command line app, so super easy to fuzz. You could even fuzz this with AFL in non-instrumented mode if you wanted to. Like I said, light fuzzes. For this scenario, you could use AFL, but we can also use light fuzz for it. And then I guess one of the advantages there is turning on the malloc debuggers for if you use light fuzz for fuzzing package util. And during the fuzzing process, there's a global std out, so you can check the process, see what's going on with the app. So if we do this while we're fuzzing a package util, you can see that it's outputting. Its XML file looks like it mutated some input. Can't open package for expansion. That package, that fuzzing test case, and you can just kind of monitor the app's output and just see some pretty funny stuff depending on how much it outputs during errors, for example. And you can see the guard malloc is enabled because that's at the top of the output. So minimizing crashes is another fun feature of LightFuzz. So it's a pretty simplistic approach. So the way it works is it just removes one byte at a time and runs the target with a new repro. If the target crashes, just continue on removing the bytes and keep that new repro, because we removed a byte and it still crashed. So that's good. That means we don't need that byte for the test case, theoretically. And if the target doesn't crash when we remove the byte, then restore the byte, because apparently the byte's important because it made the program not crash. So simple byte by byte minimization. And then you can see here we had a crash, XC bad access, a sec fault. We throw that into the minimizer. It tries to repro it. Once it repros it, it starts minimization, and you can see it took it down, a couple thousand bytes that it didn't even need, and it reduced the crash to there. And it's also a way to find new crashes too. So maybe when it's minimizing it, it removes bytes that make it crash at a different PC. So that's also interesting to know. So it'll catch those new crashes as well when it's minimizing it. And then supermin mode is basically just repeats the process until the target is exhausted. We've exhausted all the bytes, and we can't go any lower. We've achieved the maximum minimization on the bytes. So yeah, pretty neat features to minimize your test cases. Again, super simple way of doing it, but effective. So if we're targeting clients, we're just going to do a demo of SMB util. You essentially just capture, use Wireshark, whatever, to capture and export the protocol data. For example, if we're doing clients, you want to get responses from servers during a valid session. So we use the local client mode for LightFuzz, which allows us to still look for crashes in the app, so we still have a lot of visibility there. But we'll see later with some of the remote server fuzzing, we don't have so much visibility. We run SMB util, and then we're going to listen. So it's got a built-in fuzzing server that's going to listen on 4455. We're going to tell SMB view to connect to our host and view SMB stuff at 4455 instead of 445, which is the default port. Give it some responses, and then -p is going to tell us to fuzz a session. So with LightFuzz, you can fuzz binary sessions. So this is saying that I've captured a session, SMB session of responses at this directory, and to parse those responses and fuzz with them. On to servers, so you can pick different servers. For example, there's some remote management stuff with Mac, which is like a VNC type server. Screen sharing is more like a VNC server. Some interesting Mac nuances there. And again, capture the stuff flying across the data or flying across the network, and start fuzzing. It's actually a great blog post too on the red teaming blog post on some of this, the ARDAgent and things like that you can check out to get some more information on how they work. So we can use LSOF and check and see the ARDAgent is listening and what port. And then we can run, so if we were able to run this in a debugger, like sometimes you can run it standalone. Some of these servers you can run standalone as a in a debugger, or you can attach to them too. So you kind of got to play with things here to see, how the target likes to be interacted with. And then we can pick UDP fuzzing, and if we're doing on a remote server, that address, and that's going to fuzz UDP packets from our input that we captured and send them over to the target listing on that port for ARDAgent. So this is where using crash report comes in to monitor for crashes. There's also some features like that. You can also do packet sniffing and kill everything when no more packets are going on, and run a debugger, things like that. So there's a lot of different ways to catch crashes here. And then we can see that ARDagent is receiving our packets, and it's should be parsing our packets as well, using the dtrace command to see what's going on while we're fuzzing. Similar with screensharingd, we're going to look and see what's listening. Some of these processes, LaunchD only runs like screensharingd when you get a connection, which can be interesting because sometimes you need to sleep. If you want to attach to a process, for example, you need to connect and then sleep and then attach to the process because then you'll get the PID to attach to, stuff like that. And then we can fuzz a screen sharing session based on what we captured remotely or locally, and use the crash report to capture crashes as well. This is what we're doing here. We're looking at report crash. We're saying anything that looks like screensharingd that you get a crash file for, let me know because I'm interested in that, and that would be I would mark that as a crash and start copying over repros and stuff. Interesting one when just trivial fuzzing. This one looked like a CPU exhaustion bug when fuzzing screensharingd. But it just gives you an example of some of the stuff you may come across when fuzzing. So as far as bugs go, it's still, some research is kind of still ongoing. It's kind of early, honestly. But Fuzz bugs out of a few different components: AppleScript, ColorSync, syslog, also parsing some interesting stuff, and some more upcoming CVEs. So pretty successful so far, and lots more to come. So maybe you're more interested in fuzzing on Mac now. Maybe before it was kind of this, I don't know, it's different than Windows and Linux, but now maybe you're more motivated and can see that, there's a learning curve, but there's decent amount of attack surface like every other OS, Windows, Linux included. You got to work around some security features, but it's not too bad. By default, though, Apple has spent a lot of effort locking down a lot of debugging features, which, if you're going to, get down for research, you need to turn off so in order to get more visibility into the system. And some of the tooling, even unconventional techniques in fuzzing can still yield good results. And pretty fun stuff. So thank you very much for your time, and that's the end of my stuff.